Hello, everybody. My name is Martin. I am PhD student at IWAIT University. Today, I'm going to talk about my research. Title is Study on Automatic Flex Surface Segmentation of Stone Tools by Calculating Shape Features. This is an outline of my presentation. What is stone tools? It is archaeological findings that dating back to the Paleolithic period of Japan. Ancient people hit a rock with a stone hammer to make stone tools, and it produces stone tools on flakes. The assembly of stone is crucial for analyzing ancient human activity, such as how they did stone tools, so on. When these stone tools are assembled using computer, flex surface for each stone must be extracted. So our study's purpose is automatic segmentation to extract flex surface from stone data. Related work. First work is the point cloud library, and second paper is normal vector estimation using a viewpoint. It using viewpoint, so it's not useful for further process such as segmentation. And the last one is the normal vector estimated more precisely. So it doesn't consider the orientation of normal vector. This is a result of regional segmentation in PCL. It's a failed our data. Why it is failed? It's cause of the normal vector calculation. In, normal vector calculation orientation is ambiguous. Regional segmentation. Its main point is the new region is considered if difference of parameters is greater than threshold value for neighboring point and that given point. So other cases, neighboring point is considered the same region and extend the region. These parameters are point curvature and point normal. The two parameters can be computed by principal component analysis or PCA. In PCA, for the create covariance matrix and find its eigenvalues and eigenvectors. And minimum eigenvectors eigenvalues stand for the normal vector, and curvature parameters can be computed this equation. And there is the issue. It's a normal vector orientation issue, as shown in this image, which vector E2 or E1 is which vector is normal vector orientation is undefined. So we try to solve this. Our proposed method's main point is point normal vector is always direct to be outside of the object. So if we can define which region is outside, so it's sufficient to normal vector directed as outside. And our method has four steps. First is voxelization. Voxel space is divided into same size voxel size groups and finding initial voxel size by this equation. And voxel in voxel space is all indexed, and so it's making easier and faster to find the neighboring voxel and other operations. And our method has three type of voxel states: external, internal, and surface voxel. Voxel cube has one of these states. And so we consider all voxel marked as I and meaning internal. And if a voxel contains any point, it's marked as S and meaning surface voxel. After that, we choose index vector is 0, 0. It's marked as O, and it's a seed voxel for the flat filling algorithm. And if state is I, it's flooding and it isn't stopped. After that, we can define uh, voxel state defined correctly. So sufficient content to use 3D flat filling algorithm is surface voxel must be closed, and smaller voxel size increases our method's accuracy. So it's very important to find the minimum voxel size for closed space. And after 3D flat filling algorithm, we check center voxel. If a center voxel is inside voxel, there is no issue. And if it doesn't, it's a mean surface is not closed, and it means it needs to voxel size is need to be larger. So we run the flat filling algorithm and again check in center voxel until center voxel becomes internal voxel. After that, we can define voxel states. And next step is determining normal vector orientation. An infinite line and defined by point and its normal vector has intersected through voxel in neighboring voxel. And these two intersected voxel gives 5 possible combinations, and they are here. And our method's main point is normal vector directed to be outside. So if we choose more outside voxel as a normal vector direction, so it's different. There is no problem. We choose more after, and it isn't different. It's another purchase. For example, combination LCS, we extend the searching area and for, from first-ring neighbors to second-ring neighbors. And if we don't find different combination, and we extend it again in same manner until we find different combination. And another is overall combination. And in that case, we divide all voxel in voxel space and check again, find again combination. And if we, after dividing the outside turn to the outside surface after dividing. And we implemented our algorithm in C++ and tested. We examined 44 standpoint clouds. And our method we evaluate our method, compare our result to calculated normal vector from triangle mesh, And if angle difference is greater than 90 degree, we consider it incorrect. Uh, and this shows failed points, and black points are failed points, and it appears to the next to the sharp edge. And this is a result of other result. And normal vector estimation result table, average accuracy is 99.98. And this is a result of segmentation. And this image is a picked image. An archaeologist uses this image for extracting flex surface. Number of flex surfaces is 8, hour is 6, accuracy is 75. And this is another result, accuracy is 83%. Our study estimated the normal vector directly from a 3D point cloud to one reasonable segmentation, and it determines normal vector direction by using unique space subdivision for performing reasonable segmentation. We confirmed that our method is effective for instant tool segmentation. Thank you for listening. My presentation. Thank you very much.